Hello everyone, my name is Liron, and in this video I would like to compare Rust and C in order to see the difference between the two languages. And to be honest, the reason I decided to make this video is because I am sick and tired of seeing online resources that are quite biased towards Rust, and it seems there are a lot of Rust fanboys out there that are making videos um, or writing articles in praising Rust, and it's quite annoying. Rust does deserve a lot of uh, praising, but I want an objective uh, truth to be out there. So in this comparison, I would try to be as unbiased as possible. Let me clear the screen. And yeah, so um, uh, this is a function. Also here, this is the Rust code, this is the C code, obviously. So this function takes two numbers, one bottom and one top, and goes over those numbers and the numbers that in between them, filtering only those that are even numbers and summing them up. Here again, bottom and top, right? Filtering only the even numbers and summing them up. This function was actually taken from here, from this guy, code report. This is the title he gave his video, seemingly unbiased title, which imply that this video is going just to be nothing more than a statistical review or demonstration from C to C++ to Rust. No, even not even implying any bias towards anyone. Well, maybe that's not true, because according to these arrows, there seems to be a line of advancement from C to C++ towards Rust, so perhaps I should have noted it and take it as if this title declares that Rust is the final destination. Well, maybe yes, maybe not. It is what it is, anyways. By the way, sorry if I sound a bit rushed. That's because YouTube compels me to make the video less than 15 minutes, which is probably a good thing, anyways. So yeah, let's compile the code. So let's go back to the C directory. C sum zugi.c minus o sum, sorry, zugi. We'll use minus o to optimization level in order, because many developers recommend it, and in order to get the best results we can, March native, we'll also use the native architecture of this computer, this PC, to squeeze the best result out of it. As you can see, the code compiled without any errors. Let's run it. Sum zugi, and yeah, so the sum function is doing what it should, and this is the result. It's a very big number. The number itself doesn't really matter. As I said, the reason I chose these two limiting numbers was in order to get the difference between the two visual or visible. And yeah, so here's the time. By the way, I measure the time before the function starts and the loop starts, and afterwards once again. Here I measure it and then measure it once again, and lastly, the last row is printing it to the screen. So yeah, 21 minus 16, it's 5 seconds. Let's do it once again to verify. So this is the C code. Yeah, C code. 75 minus 70 is 5 seconds. As you can see, the C code, which ran 100,000 loops of calculating the sum of numbers between -2 and 100,000. It took 5 seconds to execute, to complete. And let's see the same in Rust. And cargo run, and yeah, it's the same sum result, but as you can see, it will continue to execute. Actually, I've already tested before, and it will take almost 7 minutes. The reason it does is because this is compiled with no with debug mode, which is purposely made slower in order to add more testing and debug symbols, so that it would be easier for developers to debug. So it is what it is, as you can see from the clock here below at the right side of the screen. It already has taken more than 5 seconds, way more, and it will continue to run up to almost 7 minutes. So I'll abort it now. So in order to make this comparison more fair, we should run it with the release mode, which will be much faster to execute. As you can see, 77 versus 75, meaning 2 seconds to complete. Once again, in order to verify it's coherent, 94 minus 92, yeah, 2 seconds. So 2 seconds in Rust versus 5 seconds in C. So what is going on here? Are all those Rust fanboys out there correct? Well, not exactly. So some of you will say, well, the release mode in Rust is actually using the -03 optimization level, and you in your C code compiled it only with the level 2, which is less optimized. So let's see. I've compiled it now with -03 optimization level. Let's run it, and 43 minus 41 is 2 seconds. Once again to verify, 51, 49. So 2 seconds. Well, it seems we get a comparable result. Rust and C are comparable. It's the same. It took the same time to complete. Well, not exactly. So it turns out that in C we can optimize it to even better speed if we use the -OS flag or optimization level, which optimizes it for size. And see for yourself. Here's the result: 87 minus 87. Okay, less than 1 second. Once again to verify. Less than 1 second in C. To make it fair, we need to use the same in Rust. So how do we optimize for size in Rust? We change the toml file, and let me see. Yeah. So here we have the optimization levels. So S flag is to optimize for size, Z also for size, but it also turns off loop vectorization, which we don't want. So we'll use the S, and in order to do so, we'll copy that, put it here, opt level equals S, save it. Yeah, it's saved, and execute. So 2 seconds, let's see with the optimization for size how long will it take. 62 minus 58 is 4 seconds. Once again, let's do it. 73, 69, 4 seconds once again. So what can we learn from this test? Okay, these are the results. As you can see, first of all, the number of characters in this file, 500, whereas, oops, this is not the right file. Let me delete that. Okay. And versus only 379, so less characters in C. And also execution time in C, less than a second versus about 2 seconds in Rust, which is the best result I could extort from it or squeeze from it. If you have any suggestions or corrections, I would love to hear or read about it. Please don't be shy to do so in the comments below. And yeah, I'm finishing this up because time is limited. Yeah, goodbye and peace out.